Okay, how you guys doing? Hopefully you're doing better than me. This is Thursday, January 14th, and I'm getting ready to do section 404. If you notice, I'm kind of gimping around here. I don't know if I did something the other day. I pulled a muscle, pulled my hamstring or something, so kind of gimping around here. So hopefully I'll be feeling better by Tuesday when we get back together. So anyhow, again, we're getting ready to start section 4-4. I want you guys to start this assignment on the 15th, Friday, January 15th. And we're going to tentatively have this thing due next Thursday, January 21st. This is a tougher section. Okay, it's all about factoring. Lots and lots of factoring. We've done some factoring throughout the year. This gets a little more confusing. Okay, so we're, like I told you guys a few months ago, we're not done with factoring. Factoring will pop up every now and then. So anyhow, not an easy section. Definitely not. So the good news though is that, like I say, we're supposed to be back here on Tuesday. So we'll have Tuesday and then also Thursday that you can ask me questions in class, and you guys will be able to work on them in class. So I'm not going to even have to be lecturing. You have the entire 2 class periods to work on the assignment, and you can always refer back to this video. So anyhow, section 4.4, more factoring, okay? And what's tough about this is there's lots, depending on the problems, there's lots of different ways of factoring, okay? So we're going to look at different techniques that you're going to be using, okay? And we're just going to dive in here on section 4-4, and we're going to start on question, what is this, 5, is it? Question number 5. Tell you what, I'm going to grab my textbook so I don't have to keep on squinting at this computer screen. Should have got that before, I apologize. Okay. You guys ready to get back here on Tuesday? I know I am, other than my leg gimping around here. So, okay. Section 4.4. Okay. Starting on question number 5. So, question number 5. They want us to factor factoring stuff because they ask you to factor completely, okay? So what we mean by that is, you can factor, but sometimes you don't factor enough. Like, for example, simplifying fractions. If I give you 10 out of 20, somebody says, let's simplify to 5/10. They're not wrong, but they're not totally right, okay? It is simpler, but not in simplest form. So factoring always means factor as much as you possibly can. So we have x3 minus 2x squared minus 24x. Okay, the first thing we always try to do whenever we factor is look for a common factor. In this case, there is an x that's common to all of them, so we can factor an x out. X times x squared is x to the third, minus x times 2x is 2x squared, minus x times 24 is 24x. Now, we factored it? Sure. Completely? Probably not. Okay? We look at these 3 terms. We're going to draw our 2 sets of parentheses. We look at x squared. This x, it's there. We're just ignoring. I'm going to write it down, but we're done with that for now. X squared is x and x. And then if you remember, we look at our last term. We don't look at our middle term yet. To make a negative, we multiply a positive and a negative. Okay? We want to times 2 numbers to get negative 24, but add 2 numbers to get to negative 2. Okay, and again, I've said before, if you know your times tables, it makes factoring easier. If you don't know your times tables really well, it makes it that much harder. So to times to negative 24 and add to negative 2 would be a positive 4 and a negative 6. Okay, because they times to negative 24, they add to negative 2. Now, since everything is to the power of 1, you're done. Okay, that's the hardest part of factoring, is knowing when you're done. Okay, does it factor further? Now I want to make sure we're very clear on this. If everything gets to first degree, if there's no squares or cubes or fourths, if everything's first degree, you're done. That doesn't mean everything gets to first degree, but if you do get everything to first degree, you have nothing else that you have to do. Okay? Number 7, we have 3p5 minus what, 192p3. Make sure when you type these in, you use p's, don't use x's. The computer won't like that. 3 actually does go into 192. And both of these have p's, but not just p's, they both have at least p to the 3. So I can take out a 3p to the third. What do I times 3p to the third by to make 3p to the fifth? P to the second. Minus 3 times what's 192? I don't expect you to necessarily know that one, but it's 64. And I took a p3 out of p3, so there's nothing left. Now this does factor further. If you only learn one thing with factoring, this is what you need to know. A difference of squares. Difference means subtraction. And squares. P squared is obviously a square. P squared, and 64 is 8 squared. So that factors to p plus 8. And p take away 8. And we have a p3 out. Oh, oops, that's a p. Okay, now this is not first degree, but it's only one term, so that doesn't factor. You can't, if you only have one term, you can't factor just one term, okay? All right. Question number 9. So we have 2q4 plus 9, 2q4 plus 9q, 3 minus 18, q probably squared. Okay. So what goes to 2, 9, and 18 besides 1? Nothing. But I can take a q out of all of these. I can actually take q to the second out of all of these. Okay? So I take q squared times what gives you 2q4? 2q squared. Looks terrible. Plus, take q squared out of 9q3, we're left with 9q. Minus, take q squared out of 18q squared, we're left with 18. Now, does this factor further? I don't know. Honestly, don't know. Okay, I'm going to cheat and look in the book right here. Yes, it does factor further. Okay. Now, if you're wondering, how are you supposed to know if you can't look in the book? Okay. Well, here's the deal. If I didn't look in the book, what I would do is try to every single possible way of factoring this, and if none of them work, then it wouldn't factor any further. But this does factor further because I looked in the book right there. Now, to make 2q squared, it's going to be 2q times 1q. We look at our last term, it's a negative. We times a positive times a negative. Now, back here, it didn't matter where I put the plus and the minus because our first terms were the same. Here, does it make a difference where I put the plus and the minus? Yes, it does, because my first terms are not the same. I'm going to put plus minus. How do I know that? I don't. I'm guessing. Okay, I honestly don't know. Okay? And that little trick about timesing to this and adding to that doesn't work on this because it starts off with a 2q squared. That times to this, add to that only works if that's a 1. Here it was a 1, so times to this, add to that, it worked. So we still want to times to get 18. So there's 1 and 18, 2 and 9, and 3 and 6, okay? I don't know which one it is, okay? I'm going to guess 3 and 6. I'm just going to guess, okay? Now, if this doesn't work, we're going to switch our 3 and our 6. And if that doesn't work, we'll try 2 and 9. And if that doesn't work, we'll switch our 2 and a 9. And we'll go to 1 and 18 or 18 and 1. We're just guessing, okay? So we FOIL this out, but we know our first terms are good because we have that, and we know our last terms because 3 and 6 is 18 when you times. If I check my outers, that's a negative 12q. If I check my inners, it's a positive 3q. 3 and negative 12 is a negative 9q. Do I want negative 9q? No, I want a positive 9q. So it's close, but I got the opposite answer. So I need to change these to minus 3 and plus 6. If I want to check it, I can. But when you change these signs, all the signs change. That's what I want. Now, this isn't our final answer. Don't forget the q squared. And this doesn't factor any further because these are first degree. That's second degree, but it's only one term. Okay? Let's look at number 11. 11. Okay. Number 11, we have 10, W10. And what? Minus 19, W9. And what? Plus 6W8. Okay, so what goes to 10, 19, and 6 besides 1? Nothing. But I can take W to the 8th out. Take W to the 8th out of 10W10, it's 10W squared. Minus, take W8 out of this, we're left with 19 W's. Plus, take W8 out of here, we're left with 6. Does that factor further? I don't know. Okay, I'm not going to look at the book. I'm not sure. I think it probably does, but we'll see. Now this one's even tougher because to make 10W squared, to make 10 it can be 2 and 5 or 10 and 1. I don't know which it is. I'm going to guess 2W and 5W. It might be 10W and 1W. We don't know. We look at our last term, it's a positive. So to make a positive, it's either positive positive or a negative negative. We've got to get negative somehow, so it's going to be a negative negative. Okay? To make 6, it's either 1 and 6 or 2 and 3. And they're not going to add up to 19 because that's a 10. That doesn't work, okay? So I'm guessing 3 and 2. Totally guessing right here, okay? Actually, I'm going to guess 2 and 3 first. Let me guess 2 and 3. We check our outers. Negative 3 times 2 is negative 6W. Inners is negative 10W. Together, that's negative 16W. We want negative 19W. Does that mean 2 and 3 is out? Not necessarily. We can put the 3 here and the 2 here, and that makes a difference because our first terms are different, okay? So, we check our outers, that's a negative 4W. Our inners is a negative 15W. Together, that's a negative 19W. That's what we want. Don't forget the W8. Doesn't factor further because they're both first degree. There's only one term there. Number 13, okay. These next ones. At first, they can be confusing, but then they get easier, okay? They do get easier. Now, let me jot this down before we do number 13. We've already said a difference of squares. Difference of squares If I add like a squared minus b squared, difference means subtract, a squared, b squared, they're two squares. That factors to a plus b, a minus b. So if I gave you x squared minus 25, that's x squared and 5 squared. That factor to x plus 5, x minus 5, okay? So you want to jot these down in your notes, okay? There's also a sum of cubes formula and a difference of cubes factoring formula. Okay, a sum of cubes, if I had a cubed, sum means add, plus b cubed. It factors to a squared, I'm sorry, not a squared, a plus b, a squared minus ab plus b squared. You might want to jot that down. Difference of cubes means you subtract two cubes. That factors to a minus b, a squared plus ab plus b squared. Okay, that's tricky because they're very, 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 very similar, okay? Now, I've given you a list of squares before. I would really encourage you guys, add to that list of squares. I always tell students to write it right on the back of your folder so you're not going to lose them. So squares 1, 4, 9, 16. And I don't want you to memorize this list. I want you to understand it. Why is 36 the sixth number on the list? Because that's 6 squared, 6 times 6. Ninth number is 9 times 9, 81. Cubes, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3, 3, 3, 4, 4, 4, 5, 6, 7, 8, 9, 10. Okay? So, let's look at number 13. Number 13, they give us x cubed plus 64.